When sizing a disconnect or pull-out for air conditioning units, the crucial factor is the unit's maximum amperage. The National Electrical Code, known as the NEC, mandates that the disconnect be sized according to the minimum circuit capacity specified for the air conditioner. This information is typically located in the unit's nameplate or within its specifications. The minimum circuit capacity is generally calculated as 125% of the air conditioner's maximum amperage. It is also acceptable to size the disconnect for the maximum amperage of the air conditioner, representing the highest amperage the unit might draw during standard operation. This value can also be found on the unit's nameplate or in its specifications. Consider a situation where the minimum amperage is 16 amps and the maximum is 40 amps. Sizing for the minimum involves calculating 125% of 16 amps, which equals 20 amps. This means the disconnect should be sized for at least 20 amps to meet the minimum requirements. Alternatively, sizing for the maximum means selecting a disconnect rated for 40 amps, corresponding to the air conditioner's maximum amperage. It is generally advisable to size the disconnect for the maximum amperage of the air conditioner. This ensures the disconnect can effectively manage the unit's full load. This approach provides enhanced protection for both the air conditioner and the electrical system. In this case, it is recommended to use a 40 amp disconnect. This recommendation is based on the need to accommodate the potential for the air conditioner to draw its maximum rated amperage under certain operating conditions. Selecting a disconnect rated lower than the maximum amperage could lead to nuisance tripping or even failure of the disconnect itself. Always verify the exact disconnect size needed for a specific air conditioner unit by referring to the manufacturer's specifications or consulting with a qualified electrician. This step is essential to ensure compliance with local electrical codes and to guarantee the safety and reliable operation of the air conditioning system. The air conditioner's nameplate provides essential information for proper disconnect sizing. This includes the minimum circuit capacity and the maximum overcurrent protection device rating. These values are critical for selecting the appropriate disconnect size and ensuring electrical safety. Ignoring these specifications can lead to undersized or oversized disconnects, both of which can have negative consequences. An undersized disconnect may not be able to handle the air conditioner's full load, leading to overheating and potential failure. An oversized disconnect, while not as immediately dangerous, can reduce the level of protection provided to the air conditioner in the event of a fault. When selecting a disconnect, it is important to consider the voltage rating as well as the amperage rating. The disconnect's voltage rating must be equal to or greater than the air conditioner's voltage. Using a disconnect with an insufficient voltage rating can create a hazardous situation. In addition to the nameplate information, local electrical codes and regulations may also influence the selection of a disconnect. These codes are designed to ensure electrical safety and may specify additional requirements for disconnect sizing and installation. Consulting with a qualified electrician is the best way to ensure compliance with all applicable codes and regulations. The installation of the disconnect is just as important as the selection of the correct size. The disconnect must be installed in a readily accessible location and must be properly grounded. Improper installation can create a safety hazard and may void the warranty on the air conditioner. Regular inspection and maintenance of the disconnect are also essential. Over time, disconnects can become corroded or damaged, which could affect their performance. Inspecting the disconnect regularly and replacing it when necessary can help to prevent electrical problems and ensure the continued safe operation of the air conditioning system. It is also important to ensure that the disconnect is properly labeled. The label should clearly indicate the air conditioner that the disconnect serves and the disconnect's voltage and amperage ratings. This information can be helpful for troubleshooting and maintenance purposes. In summary, sizing an air conditioner disconnect requires careful consideration of the unit's nameplate information, local electrical codes, and the specific application. Selecting the correct size disconnect and installing it properly are essential for ensuring the safety and reliable operation of the air conditioning system. Remember to consult with a qualified electrician if you have any questions or concerns. The NEC provides specific guidelines for sizing disconnects based on the type of equipment being served. For air conditioning equipment, Section 440 provides detailed requirements. This section covers the sizing of conductors, overcurrent protection, and disconnects for air conditioning and refrigeration equipment. It is important to be familiar with these requirements to ensure compliance with the NEC. When sizing the disconnect, it is also important to consider the ambient temperature in which the disconnect will be installed. High ambient temperatures can affect the disconnect's ampacity rating. If the disconnect is installed in a hot environment, it may be necessary to direct its ampacity to prevent overheating. Directing factors are typically provided by the disconnect manufacturer. In addition to the amperage and voltage ratings, disconnects are also rated for their interrupting capacity. The interrupting capacity is the maximum fault current that the disconnect can safely interrupt. It is important to select a disconnect with an interrupting capacity that is sufficient for the potential fault current at the installation location. The available fault current can be determined by performing a fault current study. There are several different types of disconnects available, including fused disconnects and non-fused disconnects. Fused disconnects provide overcurrent protection in addition to disconnecting means. Non-fused disconnects only provide disconnecting means. The type of disconnect selected will depend on the specific application and the overcurrent protection requirements. Some air conditioning units have multiple compressors or motors. In these cases, the disconnect must be sized to handle the combined load of all the compressors and motors. The NEC provides specific rules for calculating the combined load of multiple motors. It is also important to consider the starting current of the air conditioning unit. The starting current can be several times higher than the running current. The disconnect must be able to handle the starting current without tripping or overheating. Some disconnects are specifically designed for use with air conditioning equipment. These disconnects may have features such as a time delay fuse or a higher interrupting capacity. Using a disconnect that is specifically designed for air conditioning equipment can help to ensure reliable performance and safety. When replacing an existing disconnect, it is important to ensure that the replacement disconnect is the same size and type as the original disconnect. Using a different size or type of disconnect can create a safety hazard. It is also important to properly torque all connections when installing a disconnect. Loose connections can cause overheating and potential failure. Torque specifications are typically provided by the disconnect manufacturer. Regular inspection and maintenance of the disconnect can help to identify potential problems before they become serious. Inspect the disconnect for signs of corrosion, damage, or overheating. Also, check the connections to ensure that they are tight. If any problems are found, the disconnect should be replaced immediately. In addition to the disconnect, it is also important to properly size the conductors that feed the air conditioning unit. The conductors must be sized to carry the air conditioner's full load current plus any applicable directing factors. The NEC provides specific rules for sizing conductors based on the type of equipment being served and the installation conditions. It is also important to properly protect the conductors from overcurrent. Overcurrent protection can be provided by a fuse or a circuit breaker. The overcurrent protection device must be sized to protect the conductors from overheating and to prevent damage to the air conditioning equipment. The NEC provides specific rules for sizing overcurrent protection devices. Grounding is another important aspect of air conditioning system installation. The air conditioning unit and the disconnect must be properly grounded to protect against electrical shock. The NEC provides specific rules for grounding electrical equipment. Proper labeling of the disconnect is also essential. The label should clearly identify the air conditioning unit that the disconnect serves and the disconnect's voltage and amperage ratings. This information can be helpful for troubleshooting and maintenance purposes. It is also important to keep accurate records of all electrical work performed on the air conditioning system. These records should include the date of the work, a description of the work performed, and the name of the person who performed the work. These records can be helpful for troubleshooting and maintenance purposes. Finally, it is important to remember that electrical work can be dangerous. Only qualified electricians should perform electrical work on air conditioning systems. If you are not a qualified electrician, do not attempt to perform electrical work on your air conditioning system. Contact a qualified electrician to perform the work for you. The NEC provides detailed requirements for working on electrical equipment safely. These requirements include the use of personal protective equipment, such as gloves and eye protection, and the use of insulated tools. It is important to follow these requirements to prevent electrical shock and other injuries. In addition to the NEC, local electrical codes and regulations may also apply to air conditioning system installations. These codes and regulations may vary depending on the location. It is important to be familiar with all applicable codes and regulations before performing any electrical work. Consulting with a qualified electrician is the best way to ensure compliance with all applicable codes and regulations. Proper sizing of the disconnect is crucial for the safe and reliable operation of the air conditioning system. Following the guidelines outlined above and consulting with a qualified electrician can help to ensure that the disconnect is properly sized and installed. Remember to always prioritize safety when working with electrical equipment. Before beginning any work, always disconnect the power to the air conditioning unit at the main breaker. Verify that the power is off by using a voltmeter. Never work on electrical equipment while it is energized. Wear appropriate personal protective equipment, such as gloves and eye protection. Use insulated tools. Follow all applicable safety codes and regulations. If you are not comfortable working with electrical equipment, contact a qualified electrician to perform the work for you. Improperly sized or installed electrical equipment can create a safety hazard. It is always better to be safe than sorry. Take the time to learn about electrical safety and follow all applicable guidelines and regulations. This will help to prevent electrical shock and other injuries. In addition to the technical aspects of disconnect sizing, it is also important to consider the aesthetic aspects. The disconnect should be installed in a location that is aesthetically pleasing and does not detract from the appearance of the building. The disconnect should also be installed in a location that is easily accessible for maintenance and repairs. The disconnect should be protected from the weather and other environmental factors. The disconnect should be installed in a location that is not subject to flooding or other water damage. The disconnect should be installed in a location that is not subject to excessive vibration or other mechanical stress. The disconnect should be installed in a location that is not subject to tampering or vandalism. The disconnect should be installed in a location that is not subject to fire or other hazards. The disconnect should be installed in a location that is in compliance with all applicable codes and regulations. The disconnect should be installed in a location that is approved by the local authorities. The disconnect should be installed in a location that is safe and convenient for all users. Consider a scenario where you are installing a new air conditioning unit in a residential home. The air conditioning unit has a minimum circuit ampacity of 25 amps and a maximum overcurrent protection device rating of 35 amps. Based on this information, you would need to select a disconnect that is rated for at least 25 amps and can accommodate a 35 amp fuse or circuit breaker. You would also need to ensure that the disconnect is properly grounded and labeled. You would also need to ensure that the conductors that feed the air conditioning unit are properly sized and protected from overcurrent. You would also need to ensure that the installation is in compliance with all applicable codes and regulations. If you are not familiar with electrical codes and regulations, you should contact a qualified electrician to perform the installation. A qualified electrician can ensure that the installation is safe and in compliance with all applicable codes and regulations. By following these guidelines, you can ensure that your air conditioning system is properly installed and will operate safely and reliably for many years to come. Remember that this is a general overview of air conditioner disconnect sizing, and its specific requirements may vary depending on the application and local codes. Always consult with a qualified electrician or refer to the manufacturer's instructions for detailed guidance.